Hi. Um, yeah, let's get right to it. This is the last week of the quarter, and the password is going to be April 14th, because that is the day that we go back to school. Some of us in person and some of us virtually. The last day of the quarter is technically Thursday. That's April 1st. So make sure you're all caught up. We have our test this week, which is due on Friday at midnight. And that is the last day that I will take any work from this unit, the green folders unit. All right. So we're just going to continue some examples about factoring, and they're exactly the same as what you've seen before, but they just look a little different, and they're what we call special cases. So they're special examples that might be kind of unique, but let's get to it. All right, so as we've talked about, when we're factoring trinomials into two binomials, we want to set ourselves up for success. So when we're factoring, we know that we just need to find two numbers. We're going to find the number that multiplies to 36 but adds to 12. So I'm going to make a chart for 36. 36 is has a lot of factors. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Lots of options here. We need to see which two of these will add up to 12. So 6 and 6 add up to 12. And so what that means is we can write our answer as plus 6 plus 6. So maybe you're wondering, why was that special? What makes this a special case? And the reason why it's a special case is because you might have noticed that this is x plus 6 and this is also x plus 6, so they are the same binomial twice. And so what is special about it is that you would want to rewrite this as x plus 6 squared. That's what makes it special. So nothing really too new, just a little extra step at the end there to make it a little bit fancier by using a square. All right, we can look at this next example and do exactly the same thing. Or we can talk about how to do a little bit of a shortcut. So something that you might notice is that 64 is a perfect square. That is 8 times 8 is 64. Well, whenever you have the number that is a perfect square, and then this middle number, it's negative, but is double, right? 2 times 8 is 16. You know that you're going to have a square. So if you're good with that, you could kind of skip over this, say, oh, okay, it's a perfect square for 64, and then 8 doubled is 16, so I know this is going to be a binomial squared. If that is not something that you are comfortable doing, that's okay. We can go about this the same way we've been doing. Again, 64 is it's gonna have a lot of factors, so we need to be careful. 1 and 64, 2 and 32, 3 does not work, 4 and 16, 5 and 6 do not work, 7 does not work, and then we have 8 and 8. All right, so looking through that list, we can see that 8 and 8 add up to 16. However, this is a negative 16. So that means that everything has to be negative because two negatives multiply to a positive, but they add up to a negative. So we're going to do x minus 8 and then squared for the answer on that one. All right, so I'll pause the video here. You go ahead and try examples 1 and 2, and we'll come back and we'll look at yet another very interesting special case. All right, I hope you're feeling successful. Let's go on to another topic. So when you look at this, it's not a trinomial technically because there's only 2 parts to it. However, our answer is still going to be 2 binomials. And the reason why is because x squared and minus 81 we could say that there are 0 x's in the middle. So really what we're trying to do is we're trying to multiply to 81, but add up to 0. All right, so let's make a list. We're going to make a list for 81. It's going to be 1 and 81. Oops. 2 does not work. 3 and 27. 4, 5, 6, 7, 8, 9 does work. All right, so here we have 9 and 9. And we know that this is not actually 81. It is a negative 81. And from what we've learned about a lot over and over and over this year, we know that when something adds up to 0, right, we create a 0, it means that it's the same number, but one is negative, and you're adding those two things together to get 0. So we create 0 with a negative 9 and a positive 9. So we have negative 9 and positive 9. And that's our final answer. All right, again, let's talk about how we could kind of recognize these and, not have to go through the whole process. One of the great things about special cases is that if you can recognize them, it saves you a lot of thought process. So if you notice that you have a negative number that is a perfect square, and you have another thing that is being squared, you can call this a difference of squares. Difference of squares. And so the big idea is that this is x squared minus, and then 100 is 10 squared. And because we know that the two numbers need to add up to 0, we know that it's going to be a positive and a negative of the same number. And so that's why it's called a difference of squares, because it's two squares being subtracted, and you can recognize that right away, and then recognize that it needs to be plus 10 and minus 10. Of course, you do not have to do this. This is just a strategy. If you want to go through and make the list for 100, feel free. So 1 and 100, 2 and 50, 3 does not work, 4 and 25, 5 and 20, 6 does not work, 7 does not work, 8 does not work, 9 does not work, 10 does work. And then again, we recognize that it needs to add up to 0, and it's not 100, it's negative 100. So one of these 10s needs to be negative, negative 10 and positive 10 add up to 0. And so feel free to keep using the old strategy if it works better for you, but if you get to that point where you can start recognizing difference of squares, or in the previous set, that squares, the binomials that are repeated, it can save you a little bit of time. All right, so notice here we have two squares, right? We have x squared, and then we have 5 squared. However, the number in between is a positive. So when you see this, this is going to be not factorable or unfactorable. That's another way to say it. And let's talk about why. So we have 25. And we need to find 2 of the factors of 25 that add up to 0. However, that needs to be a positive 25. So it could be 5 and 5, but that makes 10, not 0. And if we made it both negative, that would be negative 10 and not 0. So there's no possible way to do this, so we call it unfactorable. All right. Oh, and then if you want to know, so the special cases, because when they're factored, they create a square, right? Squared binomial. And then here we call this difference of squares. That's what we call this type of problem here. All right, and that's going to be it for me. I hope you're feeling successful. Remember, this week is the last week of the quarter, so get in touch with me if you have any questions about late work or due dates. We will be doing our assignment session on Friday at noon. So if you want some help studying for the test or working on the homework from this week, go ahead and come to that study session. I can't wait to see you in FJ Office 10.